Today I'm going to talk about LeetCode question number 684, redundant connection. So in this problem, a tree is an undirected graph that's connected and has no cycles. You're given a graph that started as a tree with n nodes labeled from 1 to n, with one additional edge added. The edge has two different vertices chosen from 1 to n, and it was not an edge that already existed. The graph is represented as an array edges of length n, where edges I is equal to the edge from A to B. Indicates that there is an edge between nodes A and B in the graph. Return an edge that can be removed so that the resulting graph is a tree of n nodes. If there are multiple answers, return that occurs last in the input. So basically, for this question, it's asking us. So basically, we originally had a tree here. So like a graph here. A graph 1, 2, 3. Okay, and it's asking us to find the extra edge that was added that made this turn this graph into that added a cycle to this graph. Okay. So basically, in any non-cycle graph, basically, and it has n minus 1 edges in any non-cycle graph, okay, where n is the number of nodes. But if we add a cycle, if we add an extra edge like this, then basically we've added a cycle because the number of nodes equals the number of edges. So this problem is a good candidate for a union find algorithm. Okay, this algorithm is a good algorithm to find any loops in undirected graphs. Also to find any connected components in a graph. So basically there are two parts to this algorithm, the union and the find. So what the union does is it takes two nodes that have edges between them, and it joins them. Okay, so if we have here 1, 2, we have 1, 2. Okay, if we have 1, 3, okay, so what we want to do here in this case is, since we already have a 1 in this graph and we don't have a 3 actually, what we want to do is join the bigger graph. Join the smaller graph to the bigger graph. So if we have 3 here, obviously this guy is bigger. So what we want to do is join it like that. And also previously when we had 1, 2, we want to join the bigger graph to the smaller graph. But since they're of the same size, it doesn't matter if we do 1, 2, 2 or 2, 2, 1. But I'll just have it like this in this case. Okay. And also, every time we do a union, we want to find the parents of each node if they already exist in the graph, okay? How do we find parents? So basically, what we want to do with this union find is keep a parent array, okay? And it will keep track of parents for all the nodes from 1 to n. So initially, all the nodes were single nodes and they were parents to themselves. So 1, 2, 3. Okay, we can just think of it like this: parents to themselves. Okay, and after we did the first union of 1 to 2, we check the parents of 1 and 2 first. We see 1's parent is 1, 2's parent is 2 of itself. So we want to join the smaller graph to the bigger graph. And how do you know which graphs are smaller or bigger? Well, we have another array called it's another array called weight, I think. Or rank, sorry. So we'll have another array called rank, and this will keep the size of the graph we have so far for each node. So initially they'd all be 1, size 1, because they're single nodes at first. So now that we join 1 and 2 together, basically, since 1 is the parent, its size will be updated to 2. Okay, and since nothing is connected to 2, its size will stay 1. Okay, now if we want to join 3, 3 and 1, so basically we find the parent of 1, which is 1, the parent of 3, which is 3. Okay, that means we can join them together. So we join the small graph to the bigger graph, smaller, bigger, okay, and then we do that, and then we update 1's rank to 3. Okay, now how about if we want to join the edges 2 and 3? Oh, I forgot to update the parent of 2 to be 1. Okay, and 3's parent is now 1 also. Okay. So now what if we want to join 2 and 3? First we find the parent of 2. Okay, that's 1. Then we find the parent of 3, which is 1. But wait, they're the same parent. Okay, that means there's already a path that exists between 2 and 3 through the parent here. So that means if you do connect 2 and 3, you know, like this, well, we're basically adding a loop. And basically the first instance where this occurs, where the parents are the same, that's the redundant edge here. Okay. Okay, now to code it up, so what I want to do is define my parent array and my rank array. Okay, and I'm gonna fill it up for each of the edges we have. Okay, so and basically we're guaranteed a loop in the edges, so that means that we'll have there'll be the ratio of edges to nodes will be 1 to 1. So I'll just go like this. So for I in range when edges plus 1. And why did I do plus 1? Well, we have nodes labeled from 1 to n, and just in the interest of indexing, like 0, 1, 2, 3, I just want the node 1 to be position 1, node 2 to be position 2, etc. This guy will never get used, but just in the interest of the indexing and lookup in the array, I'll just have it like that. So for that, we're going to do, so for I in range length of edges plus 1, we're going to do parent dot add and I rank and 1. Okay, because remember each node is going to be a single node by itself, and it'll have a length of 1. Okay, or sorry, 0. It won't. It's not. It's a parent to 0 edges. And then is it 1 or 0? Yeah, it could be 1. It could be 1. Okay. So now that we have that, what we're going to do now is define our union function. Or before I define union, I'm going to define find for n here. And what we're basically going to do here is find the parent of the node. So we basically want to find the root parent. So even if like a 4 was connected to 3 up here, we want to find the very first parent. Okay, so pair is equal to parent node, and while parent is not equal to parent of itself. Okay, because remember, if a node is like the head here of, or is like the root node, then it won't have a parent, so its parent will just be itself. So what we're going to do is parent equal to parent p. Okay, and finally return, or not p, parent, and then finally going to return parent. And now for a union, and by the way, this is going to run in O of n time. This union find is O of n. So union between node 1 and node 2. So well, first what we want to do is find the parents of node 1 and node 2. We want to check if they're the same. If they're the same, then basically that means we have a cycle. That edge is a cycle. We'll return false. That will make more sense why we return false later. Okay, else what we want to do, if the rank of parent 1 is greater than or equal to the rank of parent 2, so if the graph starting at the root of parent 1 is greater than or equal to the graph size at parent 2, where parent 2 is a node, then what we want to do is join parent 2 to parent 1. So parent 1 and parent 2 and parent equals parent 1. Okay, else we do the opposite. Okay, and finally after all that, turn true. And finally, outside these functions, what we're going to do is iterate their edges. So for I in edges, if union between I0 and I1 equals false, then return I basically. That means that's the the redundant connection. Okay, pretty much it. I'll compile it. Okay, I'll add more test cases to this. Okay, now I'll try submitting. Okay, great. Thanks for watching.